Okay, good morning, guys. Assalamu alaikum. Welcome back to Inspire Teens Grade 11 Mathematics, where in today's lesson, we'll be continuing with functions. Okay, so just to quickly recap. Okay, we won't recap all the different things that we've done because there's a lot that we've done. But basically, just to discuss it, we've done parabola, hyperbola, exponential, okay, the main three functions, the different functions, and calculating turning points, x-intercepts, drawing the functions, and all of those good stuff, okay, the different types of general formulas and all of those things, okay. Now, today, we are going to discuss, we're going to start off with discussing transformations to graphs, okay, and then we're going to continue with, hopefully, discussing vertical distance, horizontal distance, maximum distance, those things, okay, roots and parabolas, intersections of graphs, and hopefully get to intervals. I know that intervals is like the last part that we're going to discuss, and I feel like maybe a lot of people struggle there. That's a difficult part. So yeah, today's lesson, we're probably doing the hardest stuff of functions, right? Yeah, generally noted as the more difficult things. Okay. So give me 1 second and then we can start. Okay. So let's have a look at the different possible transformations that we can have. Okay. The first one that we're going to discuss, okay, is negative f of x, okay, and f of negative x, and we're going to discuss the difference. So negative f of x and f of negative x, okay, and we're going to discuss the difference. So by the way, all of these transformations are being compared with f of x, okay? So the original is just f of x. And then we're going to discuss how each of these changes to f of x affect the graph. For example, what happens if we take f of x and we make it negative f of x? What this does is it reflects the graph about the x-axis and makes all y coordinates negative. Okay, so when we make it negative f of x, okay, it reflects it about the x-axis, making the y coordinates negative. I'll include a diagram at some point. I will put it in the notes. Essentially, what we're looking at is if we have this type of graph, it would turn into this graph. So if I have to reflect it about the x-axis, I would essentially flip this entire graph and would turn it into that. Makes all the y coordinates negative. For example, if this y-intercept here was -2, it would make it negative. So negative 2 is positive 2. Okay, so that's what we mean when we say we would make all the y coordinates negative. So it flips it or reflects it about the y-axis. When does this happen? When we have negative f of x. So when we put a negative in front of f of x. So remember, making it negative in front of f of x, that essentially means we're making it negative y. So it makes sense that we make the y coordinates negative. Okay, because f of x is y. F of x and y are synonymous. They're the same thing. Okay, f of x is equal to y. Okay, so if you're making it negative f of x, it's like you're making it negative y. So that makes sense. You're making all the y coordinates negative. Okay, reflecting about the x-axis. What happens when we make x negative? Because now we're having f of negative x. Okay, so here we're changing the x to negative. Okay, because f of x is y, but we're not changing f of x. We're changing what's inside of it, which is the x itself. We're changing it to negative x. So we're getting f of negative x. Okay, so that out just now. Okay, so we're making it f of negative x. So what does this mean? This means that the graph is reflected about the y-axis and we are making all the x coordinates negative. So how will that look more or less? So if I have a function like this, okay, it would turn into it being reflected about the x-axis or something like that, right? More shifted towards the right side. Or if you want to do it here, it would look like that, where your reflection point was down the middle. The y-axis itself. Okay. When does that happen? That happened, okay, and then it makes all the, okay, let's get rid of this. Okay, wait, let's do this 1 second. Okay, it makes all the x coordinates negative. So for example, this particular point here was -3, and here it will be +3 when it's reflected about the y-axis. Okay, so that's just an example of it making all its x coordinates negative. So it flips all its x coordinates while y coordinates actually remain the same. So note for this one, y coordinates remain the same, and for this one, x coordinates remain the same. Okay, whichever one doesn't change remains the same. Okay, so please just keep that in mind. Let's revise it one more time. F of x is equal to y. That's the standard that we're going to compare all of these to. The first change is negative f of x. This is making y negative, essentially, reflecting it about the x-axis, making all y coordinates negative. What about f of negative x? This here is changing x to negative, so it's reflecting it about the y-axis, making all the x coordinates negative. Here's an example of how that looks. Let's look at the next one. What happens if we add or subtract? So we start off by adding, okay, let's actually see if we can, okay, never mind, I don't think we can do it. It doesn't really matter that much. Let's work with the y once the y changes first. Okay, so the y changes. So please note these are changes to y, and I'll explain why in a bit. Excuse the pun. Okay, these are changes to y because essentially what is f of x? F of x itself is y. So this f of x could be replaced with y. So this could become y plus 3. So this is clearly a change to y. And so too is the same thing applies for the second line. F of x minus 3 is the same thing as y minus 3. So we're making a change to y. But let's have a look at when it's inside the bracket, when the change is inside the bracket. When the change is inside the bracket, it's not a change to y, it's a change to x actually, because this is not f of x. This is f of x minus 3. So I can't replace this with y anymore. Okay, I can't because it's not f of x. Okay, this is a change to x. Okay, so here we can write these are changes to x. So you must note that these are changes to x. However, okay, cool. So let's go through the changes with y. So with y, when we add 3 to y, so the one thing to remember, it's always outside of the bracket. That's the change to y. Now, when we talk about y values, okay, we want to talk about y values essentially because we're making changes to y. How do I make a change to a y value? I can either move up or I can move down because this is along the y-axis. So to make a change to the y value, I can either move up or I can either move down. And that's exactly how the changes to y are made, or that's exactly the directions in which when we make changes to y, that's exactly the direction in which the graph moves. So when we add, we move up. So f of x plus 3 shifts 3 units up. F of x minus 3 shifts 3 units down. Or this is f of x plus 3, f of x minus 3. So when you add, you shift up. When you subtract, you shift down. That logically makes sense. But the logic gets thrown out of the window when we discuss x, okay? But there's an easy way to remember it, okay? But let's discuss it first. So f of x minus 3. So the x minus 3 is together with the f of x. It's not separate. We have f of x plus 3 or f of x plus 3, okay? Two different things. So f of x minus 3, that shifts to the right. And f of x plus 3, that shifts to the left. So that kind of sounds opposite, right? Because if you would add, you would think you're moving right. If you would subtract, you would think you're moving left. But remember, when it comes to x coordinates, we've been dealing with this since parabola, they're always opposite. So when we think about xtp in the formula, always opposite. So what is this? This is the formula. When we think about x-intercepts in the formula, always opposite signs compared to the equation. Equation and graph, when it comes to x coordinates, they don't agree. They're opposite signs. So when we have f of x minus 3, that shifts to the right. F of x plus 3, that shifts to the left. Okay. And if we have to just copy the same concept here, when we have a graph with our axes, we are discussing movements between left and right. Okay, along the x if we want to change x values, we have to move left or we have to move right. Okay, so f of x plus 3, f of x minus 3, that's a change to y, up or down. Adding is plus, subtracting is minus. F of x minus 3, f of x plus 3 together, one thing. When the change is inside the bracket, that's a change to x, firstly, and opposite. So if we minus, it's to the right. If we plus, it's to the left. Okay, it's a bit tricky, okay, but it kind of makes sense when you realize that all the x's are opposite. Now, let's have a look at this, all right? We're going to discuss two things here. We're going to discuss finding the new coordinate of a transformed graph, or when they want us to make transformation to a graph, finding that new coordinate, that's what we're going to discuss. Okay, also just finding a new coordinate on a transformed graph. Okay, finding a new coordinate on a transformed graph and finding the new equation. So f of x is equal to x squared minus 2x minus 2. They want us to find g of x if g of x is equal to, sorry, one second. Okay, if g of x is equal to negative f of x plus 3 minus 1. So clearly, okay, so whenever they have it worded like this, okay, a new graph labeled g of x, okay, is formed, g of x is formed by making changes to f of x. That's fine. There's no need to freak out. Okay. Sorry, one second. Let me just refresh this. Okay, there we go. Okay, there's no need to freak out, right? That they're mixing f of x and g of x. No, because g of x was obtained by making changes to f of x. And ultimately, if we make changes to f of x, it's going to be a new graph because it can be represented by a new formula. Okay, so just keep that in mind. So g of x is obtained by making changes to f of x. What changes? Let us try and identify these changes. So the first change is it was made negative f of x. We made it negative f of x. So the graph was reflected about the x-axis. Okay, the y coordinates were made negative. Then we added 3 inside the bracket. If we add 3 inside the bracket, that actually means a change to x, number 1. It's going to be either left or right. Because it's plus, it's opposite, so left. So shifted 3 units left. Let's look at the final one. Minus 1 outside of the bracket, change to y. Because we're minusing, we move down. So shifted 1 unit down. Okay, so we've identified the 3 changes that were made to this particular graph. Okay, now what we're going to do is, let's make this a bit smaller. Oops. Let's shift it over, yeah. For now, we can always change it up. Oh, one second. Can even do that, I guess. Okay, so changes identified, there. Okay, now let's make changes to the actual equation. So firstly, f of x, okay, is equal to x squared minus 2x minus 2. X squared minus 2x minus 2. So I'm going to make the changes one by one. So firstly, I'm going to make the change of negative f of x. So in order to get negative f of x, I have to make everything in the entire equation negative, because negative f of x is negative y. This whole thing can be substituted with y. This whole thing is represented by y. So I have to make the whole thing negative. In fact, let's do this. So the first change I'm making is negative f of x. So I have to make the entire thing negative. So I multiply it out. I get negative x squared plus 2x plus 2. So that's my new equation after I've done what? After I've said negative f of x. The next thing I'm going to do, so we've done negative f of x, I'm going to label this negative f of x plus 3. But obviously, the main change is x plus 3. Okay, so I've done negative f of x. Now I'm going to do negative f of x plus 3. So how do you do this? Basically, wherever you have x, you're going to replace it with x plus 3, because originally you had f of x, but now you want f of x plus 3. Okay, and by the way, in your f of x, you had x squared and 2x. So if you want f of x plus 3, you're going to have x plus 3 squared and minus 2 into x plus 3. So here we're going to have, but remember, I already made this first change. That's why I'm still labeling it negative f of x plus 3, because I'm going to make this change, the x plus 3 change to negative f of x, not f of x, because I want to do all of them now. I need to combine them. Okay, so negative f of x plus 3, negative x plus 3 squared plus 2 open brackets x plus 3 plus 2. So that's essentially how I make this change. I'm making this change basically to find out what is the new formula. That's what I'm trying to find. Okay, I'm finding g of x, or solving, not finding. I'm solving for g of x. Okay, you're solving for this new equation. That's what you need to do. So after all those changes were made, you're solving what is the new equation of the new graph. Okay, when I made it negative, I flipped it around the x-axis, I shifted it 3 units left, and I shifted it 1 unit down. What's the new equation? So this is the method to solve for the new equation. Okay, so I've solved for negative f of x. Now I'm going to solve for negative f of x plus 3. So I just need to open this up, right? So I'm going to have negative x squared. This is going to take a few steps. Negative x squared plus 6x plus 9 plus 2x plus 6 plus 2. That's simplified all one time. I'm going to have negative x squared. Negative 6x plus 2x is going to be negative 4x. And then I'm going to have negative 9 plus 8, which is negative 1. Let me just double check that's correct. No. Okay, yeah. I think that's correct. Anyway, we'll check the final answer. Okay, so that's change number 1 done, change number 2 done. Let's go for change number 3. Okay, so most likely in the exam, they're not going to give you a new equation with 3 changes. It's most likely going to be 1 change or 2 changes at most. I'm just doing 3 changes just for the practice. Okay, and so that you understand it clearly. So now we've done negative f of x. We've made that change. We made the change of negative f of x plus 3. Now we need to do the final change, negative f of x plus 3 minus 1. We need to do that minus 1 part. So we don't have to make the change to the original. We can just make the change to negative f of x plus 3, because that's what we solved for here. Okay, so this is simple, because we just need to take this equation and minus 1 from y, because remember, now this entire thing is the new y. Essentially, this is like our new y. Okay, the negative f of x minus 3, sorry, plus 3. Negative, oh, I did have plus 3. It's like our new y essentially. So now we just need to minus 1. So whenever the minus 1 is outside of the bracket, all you need to do is negative x squared minus 4x minus 1 minus 1 again. That's the change Now we can simplify. Finally, we get the equation negative x squared minus 4x minus 2. And that is the correct final answer. So this is what? This is g of x. So therefore, g of x is equal to negative x squared minus 4x minus 2. That's the final answer for solving for g of x. Okay, so that's how we make changes to that's how we make changes to this graph. Okay, just by the way, what I'm going to do at the end, and hopefully we can start doing it now going forward, is I'll just give you guys like 5 to 10 minutes towards the end of the lesson, or even if we maybe finish early, if we have like, I don't know, if there's a lot of questions, then I'm going to give you guys like 5 to 10 minutes to, even if you want to like unmute yourself and ask a question or ask it in the chat, and then we can have time like for Q&A, just to have that Q&A session with you guys. So how do you get the first one? I don't think I got the same answer as you. How do you get the first one? So the first one is simple. Negative f of x, okay? Essentially, you're making the entire equation negative, okay? So how do you make the entire equation negative? You just multiply the entire thing by a negative. So every single sign will swap. So I have negative, and then I have the equation written in brackets, and then I distribute this negative. Okay, I distribute the negative, and I get negative x squared plus 2x plus 2. That's how I got that. The second one, okay, so negative f of x plus 3, okay, so what you want to do is wherever you had x originally, you want to replace it with x plus 3, okay, so that's exactly what I did here. X plus 3, x plus 3. I replaced it with x plus 3, x plus 3, okay, and here I did FOIL, right? I FOILed it out. So I said, so in order to simplify this, I used the shortcut here, okay? X plus b, a plus b squared is equal to a squared plus 2 times ab plus b squared. You don't have to use the shortcut. You can also just distribute if you'd like and take that extra step and then simplify it. That's perfectly fine. But I used the shortcut x squared plus 6x plus 9. And then here I just distributed 2x, 6, and then the 2 is just there. Then I distributed the negative in. Okay, so I got negative x squared minus, and then yeah, I just simplified it all quickly. So yeah, I got negative 6x plus 2, which would be negative 4x. Then I got negative 9, because the negative times the 9, negative 9 plus 6 plus 2, which is essentially plus 8, which is essentially negative 1. Okay, so just double check your calculation. Okay, but nevertheless, that's how we find the new equation after we have made transformations. Okay, that's done. Right. Now I want to discuss what happens if you basically just want to find a new coordinate on the graph. So sometimes they'll ask you, find the new turning point on g of x. Okay, so sometimes they might say, find the new turning point on g of x. Okay, so the way to do that is you take the old turning point, so f of x turning point 1 and negative 3, and you make individual changes to the coordinates. Okay, so let's look at the changes once more. We can even copy them and bring them over. Right, remember, what were our changes? Our changes were reflected about the x-axis, shifted 3 units left, and shifted 1 unit down. So this is actually where you can use logic. Okay, so because we're working on the graph. Okay, so let's do the first one. Let's reflect about the x-axis. So remember, when you reflect about the x-axis, you make y negative. So that's exactly what we're going to do. To make the first change of negative f of x, we're essentially going to make y negative. So what does negative y become? It becomes 1 and positive 3. That's how we make that change to a specific coordinate. Okay, so it becomes 1 and positive 3. Okay, so what change have we made? We've made the change to negative f of x. Sorry, we've made the change of negative f of x. We essentially make y negative. We multiply this by negative. Multiply by -1. Okay, I don't know if that looks good. We just multiply by -1. Okay, because how do we make the change of reflecting about the x-axis? We make essentially y negative. Now, 3 units to the left. Now, I know when it comes to the equation, like for example, in this case, we added 3, which meant 3 units to the left. Okay, however, in the actual graph, you're not going to add 3. You're going to subtract 3. Because you need to use logic. Whenever it comes to working with the graph, you need to use logic. Whenever it comes to working with the graph, you need to use logic. So if the graph is shifting left, you make the natural change to shift the graph left. So in this case, in order to shift the graph to the left, so I'm going to make the change of x plus 3. Okay, I'm essentially going to -3. The change that I'm going to make is -3 from x. So I'm going to say 1 minus 3. And that's going to give me -2. Now, why do I say -3? Because think of it. When you're shifting a point, when you're shifting a coordinate to the left, you are decreasing the value. Okay, and you're decreasing the x value, making the x value more negative. So whenever it comes to using the actual graph, you need to use logic. Okay, so in this case, shifting 3 units left, we -3. Shifting 1 unit down, you'd -1 as well, because that's logical, right? The y coordinate does follow logic. You're moving down, so you subtract 1 from the y coordinate. And that's exactly what we're going to do to make the next change. The next change is finally negative f of x plus 3. We're going to add that -1. So in this case, what am I going to do? I'm going to actually -1 from my y coordinate. So it's going to be 3 minus 1. So this final coordinate becomes -2 and 2. So that's basically using transformations, okay, to find a new coordinate on the new graph. So in this case, we found the new turning point on g of x, just transforming the actual coordinate. Because sometimes you may not need to find the new equation and then find the new turning point. All you can do is utilize the changes that were made and transform or translate the specific coordinate. So if you already have the turning point of the original graph, okay, you can use these steps to do what? To transform the old turning point into the new turning point, using this logic and using those changes. So reflection about the x-axis, make your y's negative. So the single coordinate, you can work with it, make y negative. And by the way, you could do these steps for any coordinate. It doesn't have to be the turning point. You can do this, this chain of logic for any coordinate. Again, it doesn't need to be the turning point. Each and every coordinate. So if I want to take this graph and shift it 1 unit to the left, done. Each and every coordinate that was on this graph is now 1 less x coordinate than it was. Each and every coordinate has shifted 1 unit exactly left. So for example, if here we had an x coordinate of 3 and here we had an x coordinate of -2, okay, when they shift, okay, this now becomes -3, and this now becomes 2 because it shifted 1, and this becomes 0. Okay, they all shift to the left. So each and every coordinate, you don't have to find always the new equation to find a new coordinate on the graph. Okay, what you can also do is you can just make that specific, you can make that change, you can make that specific change to an individual coordinate. Okay, a lot of the times it is the turning point, because that they want you to find the new turning point. Okay, so I hope that makes sense. And I hope transformations, we're not going to draw in this graph. You can draw it if you'd like, but basically essentially you need to draw that graph, right? Or you can draw this graph and make the changes to it. Okay, but yeah, that's the transformations discussed, all the different types of transformations we can make, how to find the new equations with transformations, as well as how to just find a new coordinate. that has been transformed. This you can go through. This is a summary of all the different graphs that we did. So please go through it. Now, let us discuss this. Okay, I didn't edit it 100%, but it's fine. I'll do that once the lesson is over. For now, we can just discuss it. So, indeed, let us discuss. Let me add it actually quickly. At least that. Okay, let us discuss this. Okay, vertical distance. I'll add the heading as well, but the heading here, just like the others, is distance. Okay, so there's something called vertical distance and horizontal distance that we work with in functions. It can get a bit confusing / tricky, but it's really not that bad. Okay, steps for determining vertical distance. So when we talk about vertical distance, we can have a look here, right? We're talking about the distance between A and B, right? We're talking about the vertical distance between two different graphs. Okay, and when we say vertical, we mean perfectly vertical. Anything vertical, by the way, is parallel to the y-axis, right? Naturally, because the y-axis is a vertical line. Okay, so when we say vertical, we mean perfectly straight. Okay, so perfectly straight. And what we need to understand from the basics of functions that we covered is that a vertical line, we need to always remember that on a vertical line, the x-coordinate remains constant. The x-coordinate remains constant. The x-coordinate remains constant. What changes is the y-coordinate. So if we want to calculate the distance between A and B, we don't have to use distance formula because it is a vertical line. What you can do is, okay, you can learn this, right? For vertical distance in general, I'll rewrite it again a bit neater later on when I send you guys the notes. You can say y top minus y bottom. That's like sort of a general equation that you should have in your head. In order to calculate vertical distance, you say y top minus y bottom. So if we have to do a practical example, let's give coordinates to A and B. Okay, let's say A's coordinates are 5 and 5. And B's coordinates would have to be the same x coordinates 5, but just say -1. Okay, so I hope you can see that that's, okay, let's do this. That's like somewhat reasonable coordinates for these two. Okay, so we have A as 5 and 5 and B as 5 and -1. A and B have to have the same x coordinate because they are vertical to one another. They're directly beneath one another. Okay, so they have to have the same x coordinate. Now, we have to, if you want to calculate the distance between these two, you can simply say y top minus y bottom. So 5 minus -1. That gives us 6. And if you had to use logic and look at this too and be like, oh, okay, this y coordinate here, according to the y-axis, wherever the y-axis is here, because it's not drawn, okay, is 5. And the other y coordinate is -1. So clearly the distance between them is that 6. So how do we calculate it? There's a formula that we can use. We can say y top minus y bottom, which is 5 minus -1. Okay, and that gives us 6. So in order to calculate vertical distance, we always say y top minus y bottom. So in a simple example, when it's dealing with coordinates, we can use the y coordinate minus the y coordinate on top minus the y coordinate at the bottom. Okay, and this is the steps to determining vertical distance. Okay, so what about when it comes to maximum or minimum? Right, that's more so when we focus on top graph minus bottom graph. But either way, I want you to remember, right? Okay, let's just say the top graph is f of x and the bottom graph is g of x. So we have to end up saying f of x minus g of x. But f of x, g of x. Both f of x and g of x are what? They are both y. It's like y minus y. What's the difference? Y top minus y bottom, essentially, because f of x is the top one and g of x is the bottom one. So that's essentially what we are saying. So when you say y top minus y bottom, yes, it includes talking about the top coordinate minus the bottom coordinate, but also the top equation minus the bottom equation, because the equations are y. The entire equation can be represented by y. Okay, but you'll see, we'll discuss maximum distance in a bit, but that's the case when it comes to maximum distance more. So we say the top graph minus the bottom graph. Okay, that's to determine vertical distance. Alternatively, if it's a simple example, y top coordinate minus the y bottom coordinate. Okay, and then substitute the given x value to derive your answer. Okay, we'll get there. Step 2, determining horizontal distance. Now, horizontal distance can be calculated by saying, okay, so let's firstly discuss on a horizontal line. We need to note that the y coordinates remain the same. The y coordinates remain the same, so the x coordinates change. So we say x right minus x left. That's the general rule for horizontal distance. X right minus x left. So to calculate the distance between A and B, we'd have to calculate the distance between, we'd have to subtract the x value of B minus the x value of A. So this vertical distance AB would be represented by XB minus XA. Okay, whatever those particular coordinates are, but yeah. Okay, so just keep that in mind. So x right minus x left, find the applicable x values. So x in this case, xb minus xy, largest minus smallest. It's always largest minus smallest. Even here, it's largest minus smallest because the largest is going to be on top and the smallest is going to be at the bottom. Okay, so vertical distance, y top minus y bottom, horizontal distance, x right minus x left. Perfect. Okay, steps for determining maximum distance. Okay, so now this is the tricky part. This is the hard part, right? Which I'm pretty sure you haven't done in like grade 10. Okay, we talk about maximum, or don't be shy to minimum as well. Okay, don't be shy to it being the minimum distance as well. Okay, so possible maximum or minimum distance. Okay, and don't worry, the calculations to calculate the maximum or minimum distance is the same. Okay, the concept is just max or min. It's fine. So step number 1, okay, is to determine the vertical distance. So vertical distance is top graph minus bottom graph. So now you'll see in maximum or minimum distance, they don't really give you a particular x coordinate. Okay, so you won't know the x coordinate of A and you won't know the x coordinate of B. All it is that AB is a line, okay, between the two graphs. So what they want from you is to say that AB could be here, anyway. AB could be anywhere. Anywhere between these two graphs, you could have a line. So obviously the excess would be cut off, but you could have a line anywhere between these two graphs, which is true, right? You can have a line anywhere between these two graphs. Okay, so they want to know at which x coordinate would the distance between the top graph and the bottom graph be a maximum. That's essentially technically what they ask. Okay, so you'll see once you learn the steps, you can just do the steps even without understanding. Okay, obviously you have to understand the steps, but I mean, just you don't have to understand the logic. Okay, so first thing is to say top graph minus bottom graph. So essentially, you need to say top graph equation minus bottom graph equation. So you're going to say like f of x minus g of x, and we'll do an example actually immediately. Step number 2, I'll need to end this up later again, sorry. Step number 2 is to find the XTP using the formula. XTP is equal to negative b over 2a. Okay, and then the third step is to find the YTP. So firstly, it's mentioned here, YTP is the maximum or the minimum. So the YTP value is actually the max or the min. Okay, just keep that in mind. The YTP value is actually the max or the min. So YTP is the maximum or minimum. So find the YTP by substituting XTP into the new equation. That's actually why we find XTP first, because YTP is what we actually want. In order to get YTP, we need to get XTP. Okay, so if this doesn't make any sense, don't worry. Hopefully it's going to make sense after this question. So we're going to do this example of, I think this one is maximum distance. The graph of x is equal to x squared plus bx plus c. So we actually need to do the previous questions to solve for that. So I'll just give us the equation. The equation actually happens to be x squared minus 2x. In the previous questions, we have to solve for that, but obviously we're not doing that right now. The equation is f of x is equal to x squared minus 2x minus 3. Okay. And the straight line G as sketched below, and G of x is equal to, we have to solve it also, but I'll just give it to us now because that's not what we are focused on. Okay. So G of x is equal to 2x minus 6. A and B are the points of intersection of the graph, F and G. A is a turning point. The graph also intersects the x-axis at 3. The x. Okay, I don't think any of those are important, right? Except this. Let's do this. Okay, there's our equations. Okay, those are important. Right. Let's look at the question. It says T is a point on the x-axis and M is a point on F such that TM is perpendicular to the x-axis. TM intersects G at P. Calculate the maximum length PM. Okay, so again, don't worry about this for now. I'm going to explain it in the diagram. But the main thing here, calculate the maximum length of PM. So they're telling us that T is perpendicular to the... Okay, so actually, let's go through what they say so I can explain something wrong. TM is perpendicular to the x-axis. TM intersects G at P. Okay, so they're telling us that TM, this line, is perpendicular to the x-axis. If something is perpendicular to the x-axis, it means that that line is vertical because the x-axis is horizontal, perfectly horizontal. So if something is perpendicular to it, it would be perfectly vertical. Because why? What else is perpendicular to the x-axis? The y-axis, and the y-axis is vertical. So any other line that's perpendicular to the x-axis is a vertical line. Okay, and if it's parallel to the x-axis, horizontal. So perpendicular, so they essentially just telling us it's a vertical line. They're confirming to us that it's a vertical line. So then they say calculate the maximum distance PM. So we are calculating the maximum distance of a vertical line. The maximum distance of a vertical line. So this is what we just learned. This is what we just talked about, right? It's the 3 steps. Okay, it's the 3 steps. Okay. 1 second. Okay, I'll attend to your question just now. Let's finish this concept. I'll attend to your question at the end. Okay, it's the 3 steps, okay, which we're going to discuss now on our own. And then obviously you can revise the steps to learn it when you're doing it on your own. Okay, so we want to calculate the maximum vertical distance of PM. Now you need to notice, you actually, in this question, you'll see you don't have the coordinate of T, the X coordinate. So you don't have the coordinate of P, nor do you have the coordinate of M. Okay, now you can actually easily, okay, I'll discuss that later. So you want to calculate maximum vertical distance of PM. And it is essentially the distance between the 2 graphs. Between these points, right, between A and B, it's the maximum distance between the 2 graphs between A and B. Okay, that's essentially what we're doing. So we're going to follow step number 1. We are going to say y top minus y bottom. Now, when we say y top minus y bottom, in this case, we don't actually have the y coordinates of those particular places, right? We don't have the y coordinate of P, and we don't have the y coordinate of M. Okay, but we don't need the y coordinate. That's why they want us to calculate maximum. Whenever they discuss maximum or minimum, right, you don't need that particular y coordinate. Now, you need to remember that y top minus y bottom, okay, it's essentially the equation on top, the top equation minus the bottom equation. So let's see between A and B, which equation is on top. Which equation is on top? That would be this guy, G of x. So essentially, to solve this, we're going to say G of x minus f of x. So y top minus y bottom is equal to G of x minus f of x. Okay, let's write it a bit bigger, actually. Y top, that's going to be y top minus y bottom. Now, the G of x equation is 2x minus 6, and we're going to subtract. Because we're subtracting, please use brackets, otherwise you will die, literally, if you don't use brackets. Minus open brackets, x squared minus 2x minus 3. Okay, so this is how we essentially start our first step to solve it. We take the top equation minus the bottom equation. So the top equation is 2x minus 6, bottom equation is x squared minus 2x minus 3. And we form a new equation. So this becomes 2x minus 6 minus x squared. I'm basically just distributing the negative in minus x squared plus 2x plus 3. Then I simplify this guy to form the new equation. So the new equation is equal to negative x squared, 2x and 2x gives us 4x, negative 6 plus 3 gives us negative 3. Okay, so the new equation is negative x squared plus 4x minus 3. So this new equation, it's important to understand that it represents the distance between g of x and f of x when g of x is above, greater than f of x. This is also key for us to understand. This equation, this lovely new equation, is an equation that represents the, I should add here actually, the vertical distance. The vertical distance between g of x and f of x when g of x is greater than f of x, meaning when g of x is above f of x. Okay, give me 1 second. Let's just copy this. Okay, and let us just place it in here. Okay, so here's my equation. There's another thing I want to discuss with you guys. This is the equation that represents essentially PM. Let me get rid of this. Let's use blue. It represents PM. Okay. Now, remember I told you, because I'm saying g of x minus f of x, right? I'm not specifying where. I'm just saying top graph minus bottom graph. Okay, so it represents a vertical distance between the top graph and the bottom graph. Now, actually, why I chose to specify and mention that it represents a vertical distance between the top graph and the bottom graph is because I'm just going to draw one line here. It could represent any vertical distance between the top and bottom graph. So it could represent the distance, could represent the distance here, could represent the distance here, it could represent the distance here, could represent the distance there, there. This equation covers for all of these distances. This equation that we solved for when we said, what is going on? Sorry, the pen stopped working. Just needs a breather, I guess. Still not working. Okay, give me 1 second. Let me just reshare my screen. Or can I pause it? Yeah, pause it. Stop working. We'll be up in a second. Okay, should be good now. If you guys, I'm gonna carry on talking, but if you guys can't see my screen, so if it's still like frozen at the same point, just let me know. But it should have like fixed itself. Okay, so remember I said we solve for this new equation by saying g of x minus f of x, right? Y minus y top minus y bottom. And this equation represents a general vertical distance between g of x and f of x when g of x is above f of x. So I showed you all of these lines. That equation could represent any of these lines. And in fact, we could calculate the distance of any of these lines, provided we have their x values. Okay, so for example, we could calculate the value, the distance between here and here. Remember, what stays the same on a vertical line? The X value. Okay, so in fact, if we knew this X value, we could calculate the vertical line at this X coordinate. So that particular vertical line by subbing that particular X value into this equation. If we knew this X value, we could calculate this vertical line between here and here. We could calculate that vertical distance between the two graphs by subbing in this X value into that equation. Similarly, we could do the same for all of them actually. Okay, so sometimes they might not tell you to calculate the maximum vertical distance, but they might tell you calculate the vertical distance at X is equal to 2. So how do you do that in that case? Okay, you utilize that equation and you substitute that particular X coordinate. So I think 3 would work, right? So let's just say they say calculate vertical distance between G of X and F of X. Sorry, I know it's over time. We will end shortly, and I'll give you guys time for questions. At X is equal to 3. Let's go down. Calculate the vertical distance between G of X and F of X at X is equal to 3. So your step number 1 is to find G of X minus F of X, because you'll also maybe note, maybe 3 is here. Right, X is equal to 3 is there. So you'll note that G of X at that point is above F of X. So you'll have to say always top minus bottom. So G of X minus F of X. Okay, and this is equal, we solved it. It's negative X squared plus 4X minus 3. Okay, so now in this case, all you have to do is take that equation that represents a vertical distance between the two graphs and substitute 3. So negative 9 plus 12 is 3, and I think it's 0. So I don't think this exists actually. Where in the blue moon would I find the calculator? Okay, no, but it should be right. So 3 squared is 9, and that's negative 9. Negative 9 plus 12, that has to be positive 3, minus 3 is equal to 0. Okay, so they actually at 3 it doesn't exist. Let's try 2. So if we substitute 2, we're going to get 2 squared, which is negative 4 plus 8. Yeah, let's do it at 2. Because, yeah, it's not so important why it doesn't work, but it's basically just because at negative 3, G of X is not above F of X, I don't think. Okay, so we're going to say at 2. So now all we have to do is simply substitute positive 2 in here. So into 4 minus 3, and I'm pretty sure here we get 1 because negative 4 plus 8 is positive 4 minus 3 is 1. That should be correct. So now we found the distance between G of X and F of X at X is equal to 2. So let's just say this was 2. Sorry, I guess one of them was 2. I think, yeah, whatever. Let's just see when we solve for the max one, but yeah, let's just say 2 is there. All right. So at 2, this distance is 1. Okay, I think, okay, actually, never mind. 2 was a bad number because I'm pretty sure that's where the maximum one is at 2 as well. Okay, but that's calculating the vertical distance between two of the graphs at a particular X coordinate, right? But now here we are talking specifically about maximum. Now, remember I told you maximum, okay, maximum is the Y turning point. So the max distance would be found by the actual Y turning point coordinate. So we need to find the Y turning point coordinate. And how do we do that? By first, bear with me, we're almost done. By first finding the X turning point. So we take our new equation and we find the X turning point of our new equation. So we say negative B, which is negative 4 over 2 times A, which is negative 1. So negative 4 over negative 2 gives us 2. Okay, so the X coordinate where the maximum distance is actually 2. So that's why it was a coincidence above that I chose 2. Okay, so the X coordinate where the maximum distance can be found is 2, or the X turning point is 2. So to find the Y turning point, we substitute the x turning point into this coordinate. So negative 2 squared plus 4 into 2 minus 3. And here we did the calculation actually, you get 1. So here, therefore, max length of PM is equal to 1. Okay. So yeah, basically you need to say y top minus y bottom, top equation minus bottom equation. If you're getting a specific, if you're getting the x or if you're getting the vertical distance between two graphs at a particular point, why do you divide the YTP? Okay, what do you mean by divide? I didn't divide the YTP. Do you mean like why did I substitute the XTP into the equation to get YTP? I'm confused. Could you please rephrase your question? Okay, so yeah, like I was saying, if you want to find vertical distance at a particular coordinate, you still say top equation minus bottom equation, and then you just substitute that particular x coordinate and to give you the distance between the two graphs at that coordinate. However, if you want to find maximum or minimum, you find the x turning point. Okay, well, essentially you need to understand that the maximum or minimum is the y turning point, and in order to calculate the y turning point, you need the x turning point. So you form that new equation that you form, and remember that new equation represents the vertical distance between the two graphs for when g of x is above f of x. Okay, so you use that new equation, find the x turning point from that new equation, and then find the y turning point thereafter. Yes, the XTP. So why do you substitute the XTP into the equation to find the YTP? Okay, that has a simple explanation. So let's just say we have this parabola equation. Okay, and here are the axes, the x and the y axes are like that. So remember that turning point itself is just a single coordinate. So when we talk about XTP, we are talking about this guy, the x coordinate of the turning point. When we talk about YTP or TPY, we are talking about simply the y coordinate of the TP of the turning point. So remember, in a Cartesian plane, whenever you have an x coordinate, of course, and you have the equation, to find the corresponding y coordinate, you just sub in that x coordinate into the equation. Or whenever you have a y coordinate, you can sub in that y coordinate into the equation. It's going to give you the corresponding x coordinate. So similarly here, turning point is one coordinate, right? So when you have the x coordinate of turning point, you can just simply substitute it into the main equation to find its corresponding y coordinate. That's all we're doing to get the YTP. Okay. And if there's anyone else that has any other questions, please type them in or get ready. I can unmute you if you'd like to ask them. Okay, but I'm just going to answer the question that this person had earlier about horizontal distance. So also one more thing I'd like to mention, if your Wi-Fi does cut or the connection is bad, you can always rewatch it. Okay, but now that we have time, I can re-explain it quickly. But essentially, horizontal distance is calculated by saying x right minus x left. Okay, so remember that on a horizontal line, the y coordinate remains the same and the x coordinate changes. So you don't need to use distance formula, because in distance formula, you're going to end up subtracting the same y coordinate. So it's like redundant. Okay. That's why if you know that it's a horizontal line, simply take the right x coordinate and subtract the left x coordinate. That's it. So in this case here I just gave them coordinates, xb and yb, and xa and ya. You would just have xb minus xa to get a horizontal distance. The right x value minus the left x value. Okay, to calculate the distance of a horizontal, the horizontal distance. Okay, so I know we didn't cover much, but it's just that these things take time, and I really do want to go through them in detail. I'm going to try my best to organize some extra lessons so that maybe we can speed this up, get the section done, so we can be on par when it comes to exams. I think next week is the best time to have extra lessons because it's the closest to school. Okay, so yeah, while I'm talking, again, please, this is the time where you guys can ask questions. So if you do have any questions, you can raise your hand or you can type it in chat. If you raise your hand, I can unmute you and you can verbally ask a question, or if you're confused about anything. Okay, that's that. Okay. And then what I wanted to ask, I forgot. Totally forgot. Okay, but it's fine. I guess then I don't have anything else. But yeah, just look out for later in the group or like after this lesson shortly. I'm going to send out a poll just to see, because from the feedback that I asked you guys to give, from the form that you guys filled out, many of you stated that you'd like the classes to be later, while some of you did say that you're perfectly fine with the time. I'm just going to send out another poll on WhatsApp just to see once again who if you guys would be keen to change the classes to a bit later so that they're a bit easier to attend. So yeah. Okay, the lesson is open for the next few minutes. Okay, I'm just going to mute and block my video, but you're free to leave if you don't have any questions, or you can stay if you have any questions and ask them. Okay, but the lesson, what I'll do is I'll unmute again and then just close the lesson in 5 or so minutes. But yeah, for those of you who need to leave, thank you guys so much for joining. I will see you guys next week. Jazakallah khair, assalamu alaikum, and goodbye. But again, for those of you who still have questions, I'm still here. Okay, cool. It doesn't seem like anyone has any questions. So, okay, cool. So it doesn't seem like anyone has any questions. So we shall end it there. Thank you guys again so much for joining. Okay, and I will see you guys next week.